In our Pathway to College Mathematics textbook, there are a number of sections we don't cover, but are important, I think, for mathematical background and where we won't have any required lessons. I'm going to do a few of these just to give you some background. All right, one that's in Chapter 3 is 3.4. Introductions to Functions and Function Notation. So we'll take a look at the learn and then we'll do some practice too. And I'd like to go over the objectives too. Determine the domain and range of a function. Determine whether a relation is or is not a function. Discuss concepts and vocabulary taught in this lesson. Again, that's our main purpose here. And use a graph to evaluate functions at given values. Use function notation. And use the vertical line test to determine if a graph is a function. Again, all of this is going to be under background. So I'm going to go to the whiteboard so you're not hindered by a cluster of things. I'd like you to get this down. And relations, key word in mathematics. Well, we talk about family relations, and maybe dogs even might have relations. And of course, in math, numbers may have relations. One of the best examples of this is the ordered pair, which we've been studying in Chapter 3. Now, in this ordered pair, the x value is known as the domain. So all of the x values make up the domain of something. Now, for the y value, those values make up what are called the range. So remember, domain would be those along the x-axis, which is horizontal, and the range would be those along the vertical axis. And we'll give you some examples of that. Now, they often ask in interval notation, what is the domain and the range of something? So knowing interval notation that we've mentioned already will be an important background item as well. Now, a key word in math, a function. What is a function? Well, in a series of relations, if the x element is only used once in a series of relations, we say it is a function. If the x element is used more than once, it is not a function. And you'll be asked to determine whether something is a function or not. And let's just review function notation too. Often it appears as this, that the function of x is such that, and then they'll give you a rule here. And we've seen this, and the function symbol can often be replaced with the letter y equals mx plus b. So what your y value would be is determined by what that x value is in this rule. All right, some background here. Let's go back to our regular screen here and change it. Now, I don't like to read things to you, but this is what we've just gone over. So you can pause it and read it carefully. And notice they're saying child, mother, indicating a relationship. City, state, or name of a player, and it's his or her batting average. So again, we've given you some background. You can read it carefully, but we've talked about a relation, the domain, and the range. So pause, read it over. And again, there are videos for these by the authors of our book. So for example 1, find the domain and range of each of these relations. So what you would do here as an answer is using braces. If you're writing a set here, you'd pick out the x element. So 5, 6, 6, -1. 5. Now notice when you write it, you don't repeat items. The 6 is used twice. I'll get to that in just a moment. Now for the y items then, that would be the range, would be the 7, the 2, the 3, and notice the 2 is used again. So in the set, you would only write the 2 once. That would be the protocol. Now, we did talk about what a function was, and the function is the x element is only used once. Well, here we see in A, the 6 is used twice. So where this would be a relation, it is not a function. They didn't ask us that yet, but they will be. Now, if the y element is used more than once, that is not part of that definition. It's only the x element. If the x element is used more than once, it's not a function. So in letter B, a similar thing, -1, 1, 0, that they'll get to in a moment, and then 1, 5, and 3 would be the range. I'll move it down so you can see it here. And there it is. Now in example 2, they're asking you to find the range and domain from a graph. So this is example 2. We'll raise it up so you can see it properly. Now again, range and domain relate to the axes. The x values would be those on the x-axis. So what we do is we project our graph down to the x-axis here and there. And notice both of these points are included. So in writing it in interval notation, it would be a bracket indicating that the -1 is in the system. I'm going to take this off here so you see it. And then it goes to, again, this is a 3. And we separate it by a comma, and this would be a closed system here. Now that would be the domain. Now for the range, again, we're projecting this graph to the y-axis. It's going to start here at 0, projecting that over there, and it goes up to this point, which is a 6. And again, this would be closed system. Here they go over the proper definition of a function. Again, if the x element is only used once in a series of relations, it is a function. If the x element is used more than once, it's not a function. Here in example 2, they're asking us, with this set of coordinates, would this be a function? Well, you can put it in a sort of a Venn diagram here, where you'll notice the domain is used for 2 of the values of the range. So these would be your x elements. So since it's used more than once, and we could see it in the ordered pair, there's a 2, and there's a 2. So this would not be a function. Now, how about this one? Notice that there's only one line coming from the domain to the range, and the x elements are only used once. So this would be a function. In example 4, they're asking us to use what is called the vertical line test. And I'll go over it with you in this diagram. So here we see a number of scattered plots. And the vertical line test is to take an imaginary vertical line, which is red here. I didn't get that too vertical, but you got the idea, hopefully. And then you take that line and move it across the face of the graph. Now, that vertical line, as it moves across, only intersects this point once. But as it gets here, it intersects it there and there. So this means this value of -1 is used for this point and this point. Therefore, x's are used more than once, so this is not a function. And in fact, if you go a little further to this line, you see the ones are used more than once. So the -1's used twice, positive one's used twice. This is not a function. And we use that imaginary vertical line that we pass over the face of the graph. Now, looking at this, you have sort of half of a circle, semicircle. Notice that those dotted lines, which is the moving vertical line test, is only intersecting at one point as it moves along. So this is a function. And while we're here, let's practice domain and range. Now, we're going to say, what would the x values be? Think about it. Well, it would be a bracket starting at -2, comma, going to +2 with a bracket. The bracket indicates that the item is included in the set. This is interval notation. Now, for the range, again, we're projecting these blue lines to our y-axis. So 0 is in the set, and it goes up to 2. All right, a little review. And still another example. What would be your interpretation? Is this a function? Does it pass the vertical line test? And the answer is no. At this point, it's intersecting in 3 places. And it would do that for a number of places and then only one, but it doesn't pass the vertical line test, so therefore is not a function. Now, in this background information, they're asking us to find the domain of a function. So you might recognize this as slope-intercept. If you convert the y to f of x, it's now in function notation. So what would the domain and range of a line that looked like this be? Now we plotted some points, but remember the lines extend to infinity in both directions. So this line eventually would go off in this direction. This would be our domain, our x values, to -infinity. And this line off in this direction to +infinity. And notice it's also, for y values, it's continuing down So it's coming up from negative infinity and going to positive infinity in this direction. So anytime you have a line that is positive slope and extends, we'll have this as domain and range. Now let's put in a line that would be, let's say, negative slope. Notice the values for a negative slope line would be the same, would come from negative infinity to positive infinity and come up from negative infinity to positive infinity. Now there are two others that we could give you as background at this time. I'll use the same graph. How about if we had a horizontal line, like so? Well, here, this is a special case where the domain would be from negative infinity to positive infinity. But the range now is unique. It's only this one point. And let's suppose it went through this dot. 1, 2, 3, 4. We would put that in actually braces. That would be 4. And that would be the answer for this one. And then adding one other line here. Let's do one vertically. Let's see if I can get it right on the line. There we go. What would be the domain and range of a vertical line? Remember, this is x equals a, and this horizontal line was y equals b from our other lessons here. And what would this be? Well, 1, 2, 3, 4, 5, 6, 7. It would be the range of negative infinity to positive infinity. But now the domain would only be that one value in braces, 7. Okay. Now for something like this is sort of interesting. If x is in the numerator, generally it would be all real numbers. But when it's in the denominator, we can't have a value for x that would make it 0. So what we do is we go x minus 1 equals 0, and we solve it, and we get x equals 1. So if x were a 1, it would make our denominator a 0, and what they're saying here is we would have to exclude that. We can't have any number that makes the denominator a 0 as a value. So looking at example 5, what value would we have to exclude? Well, again, just equal the denominator to 0. X equals 5. Transpose that, so we could say it would be all real numbers, but it cannot be a 5. So hopefully something easy as long as you know the protocol for it. Now in this slide, what we're looking for is function notation that I mentioned earlier. Review is good. And we usually write it this way and can always replace it with a y. So here is slope-intercept. To put it in function notation, convert that. And then often what they want you to do is to do the rule that they're giving you, which in this case it's mx plus b. And in this case it's negative 3 times whatever value of x, which they give you here. They're saying x is 4 plus 2. So we could still use our old friend the t-chart here. X, and this is f of x, which we said was y. And we want our x to be 4. So negative 3 times 4 is negative 12, plus 2 gives us a negative 10. Again, we did things like this earlier, but often this is what they're asking you to do. And let me mention that the F can also be replaced with other letters as well. G, H are some other common ones, but this is function notation. Okay, so what do you think they want you to do here? Well, this is example 6, and here's our rule, and there's our value for x. So you could make a little t-chart, and this would be g of x, function notation. And our values are 2, -1, and 0. So just putting that into this is pretty straightforward. Here would be a 13, here would be a 1. And if x is 0 here, this is going to be a 5. Remember, this is your y-intercept, 0, comma, b. Little review. Now, here in example 7, the rule is not linear because we're having x to the second. That's quadratic. So again, a t-chart is useful, and we'll be doing some of this in chapter 5. And this would be h of x. And our values are 4, 0, -3. And it's just a matter of carefully putting that value into the formula through substitution. And the values are 6 and 2 and 20. Again, the detailed work is here. We just want you to be sure you're familiar with using the protocol of substitution. In chapter 5, we'll be graphing, and we'll just take a look at this here. Plotting these points of a quadratic equation make a parabola, and more on this in chapter 5. All right, well, this will wrap this up. Again, it's meant to be background.